Okay, multiplying and dividing algebraic fractions. So, we'll go back to standard fractions first, just to remember what we would normally do. So, okay, I'm going to multiply some fractions, great. Well, hopefully we remember, that just means you multiply the top and multiply the bottom separately. So this, 2 by 4, 8 over, 3 by 5, 15. Try to simplify whenever you can, 8 and 15, no factors in common, we're done. Nice and boring and easy. Okay, well, unsurprisingly, algebraic, it's the same basic idea. So times the top, x and 3, so that's 3x, times the bottom, 2 and y. Cool, do I have anything in common? No, so I'm done. It's that easy. Okay, next guy, 5 and x, okay, that's 5x. X and 2 is 2x. Do I have anything in common? Yes, now I do. Okay, so I've got x divided by x, something divided by itself, always 1. So this is just going to be 5 on 2. That's basically it for the simple case. There's some things that will come up in a second, so I just want to run through things that you should not do. So I've got x plus 1 over x plus 2. And some people will go, oh, x over x, I can cancel those out, and that equals a half. But very quickly we figure out, no, that is most certainly not true, because say x is 5. 5 plus 1, 6. 5 plus 2, 7. 6 on 7, definitely not the same as a half. So what's going wrong? This crossing of these only works if everything is multiplying and dividing. As soon as there's a plus in there, you've got to be way more careful. Similar story, people go, oh, 3 and a 3, great, I can cancel that down. And then I can say 2 over x, and the x's cancel, and this is 2. Well, sorry son, but that ain't going to work. Let's let x equal 1, 2 times 1, plus 3, 5. 1 plus 3, 4, 5 on 4 is now 2? No, definitely not true. So, we've got to be a lot more careful than that. As soon as you've got pluses in there, you have to be a lot more careful. With this guy, you're going to then therefore tell me, well, okay, I can't cancel anything off. The x's look like they match, but there's a plus. No, can't do that. What if, though, I go, oh, hang on, 4x plus 8. There's a common factor of 4 on the top there. That's cool. Alright, so I've got x plus 2 there. And then the bottom, oh, they've both got a 5 in common, okay. And then that leaves me with, oops, 2x plus 1. Brilliant. Okay, so I've got this. Okay, is there anything to simplify? No. But, just on the face of it, not as obvious. What if now I change this to do the following? Okay. Well, we look at it again and it's like, well, I've still got an x and x, but there's pluses, like 4, 5, 8, 10, nothing seems to match up. Take out that common factor of 5, and I get x plus 2, and all of a sudden, oh, hang on, all in this brackets, they're the same. That's 4 times this set of brackets and 5 times this set of brackets, so I can cancel those two down to get 4 and 5. So, what we're going to be careful about is not making erroneous cancellations, but whenever you get something, it doesn't mean that necessarily nothing can be done. If you can factorise the top and the bottom, and then there might be something in common, might be able to keep going. So that's something else that you just got to look out for. Cool, alright. We've got this guy, slightly more annoying than our previous guys, but it's still the same idea. The only thing you've got to keep in mind is this is all one thing getting multiplied by the 4. So we've got 8x plus 4 on top. This is multiplying all of this, so 3 by x, 3 by 5, 15. Brilliant. Is there anything in common? No. Well, we could factorise to find 4, 2x plus 1, 3, x plus 5. Nothing's in common. That's interesting. We ended up almost exactly where we started, with 4 on 1, 2x plus 1 there, x plus 5 and 3 over there. That might be interesting. But for now, nothing can be done with it. Well, let's look over here. Okay, this times this, remember it's all of this times that. So we've got 6x plus 12 over this times all of that, 10x plus 20. I've got pluses in there, so I can't just cross stuff. Well, let's factorise this for a second. I've got a 6 plus 2, and I've got a 10 x plus 2. Oh, that's cool. I've got x plus 2, so that's good. 6 on 10, I can simplify that as well. So I get 3 on 5. That's suspicious. Where'd that 3 on 5 come from? oh, lo and behold, this and this were the same in the first place. So you can just cancel those straight at the start and jump straight to 3 on 5. So this is where it's good to have a little bit of an investigation on what your equations are before you even do any work on them. Because sometimes you can spot this and go, oh, I can do this, great, jump straight to the end. Be careful not to fall into traps, but you can do that a lot of the time. Cool, okay, what about this guy? Well, there's some shortcuts here, but we'll do it the naive way, just for the practice. Cool, I've got 6x minus 18 over, multiply all of that, 8x minus 24. Looks like we've got some common factors in there. Okay, we've got a 6 on top, x minus 3. We've got an 8 on the bottom, x minus 3. Brilliant. So we've got these two cancelling. 6 on 8 is 3 on 4. Well, that's interesting. There was no 3 on 4 over here before. So what happened there? Well, instead of doing it this way, another way you could have done it is to say, this top bit is the same as 6 lots of x minus 3. And this bottom bit is the same as 2 multiplied by, I can take out a common factor of 4 there, and then get x minus 3. Cool, now I can cancel off these two straight away. 6 over 8, oh, well, that gives me my 3/4. So that works a little bit faster. So, if you want, you can factorise these things as soon as they come up to see if you can start cross-cancelling. Don't have to, you can get there by expanding everything and then factorising again and eventually simplifying down, but that's the speedy way if you want to try it. Cool. Just to throw some new stuff at it, what if we want to divide? Well, we're just dividing fractions, and hopefully we remember to divide by a fraction, you just flip the second one upside down and times. You guys usually say keep, change, flip, I think now. So, let's do that. So this is just this guy times the reverse of the second. Okay, fine. This is all multiplying that. 10x minus 15 all over 4x. It looks like I've got x is in common, but no, there's a minus trapped in there, so I can't do anything with that. I could factorise it to be that, but nothing's in common, and I just end up essentially back where I started. 5 times that, 4 times that, nothing happens. So I'm not making any progress there, that's fine. So yeah, leave it as that, but you can change it to that if you want, they're both just as valid as each other. What about this guy? Well, we've got 4x plus 2, all multiplying the upside down of this, x plus 2, over. Cool, okay. Oh, well now we've got our foil thing going. Now if you need to use multiple colours, you use multiple colours. There's nothing wrong with throwing a bit of colour in there. So we've got, 8. 8x plus another 2x plus 4 over 3x squared plus 3x minus 5x minus 5. Cool. And if we simplify this a bit, plus 10x plus 4 all over 3x squared minus 2x minus 5. Cool. And from there it looks like, oh no, well, we've got a whole bunch of pluses and minuses. There's no way this thing will simplify nicely. Well, is that true? Let's go back a step for a second. We've raced through this expansion. As a general rule, you try to avoid expanding until you have to do it, because it tends to make things bigger and chunkier. So, let's think about this for a second. Maybe I should have factorised from here. So this time, I'll do things a little bit smarter. Still flip that thing upside down before you do anything else, just so you don't mess up which side's the top and bottom for the second guy. Well this guy up here, I could change to 2x plus 1. Is that right? Yep. This guy is going to stay as 3x minus 5. And I've got x plus, yeah that's right, x plus 2. And this guy is x plus 1. Can I see anything that'll cancel out? Remember that these are all full objects. Well, this isn't the same as that, it's not the same as that, this isn't the same as that or that. No, I've got a 2 sitting out the front, but nothing else is going to play ball with him, so it looks like I'm stuck. Oh dear, well in that case, nothing's going to happen. But, if we make a slight alteration to, which one will it, make this one, make that a, okay, if I make this a 2 here, actually I'll do that in purple just to say that that's different to the original question. There it is. Cool, alright, well what happens then? Well then this would become 2x plus 1, and all of a sudden, oh great, I can cancel these off. And then that would become whatever it is, 2x plus 4 over 3x minus 5, which is quite neat. Whereas if we had expanded it all the way with everything else, which I'll do in purple up here, if we had expanded the whole thing, what are we going to get? 4x squared, and you can do this in your own time if you so see fit. 4, 5, 10, 4 over, oh, did that expand the exact same way? That's interesting. Of course it did, because I changed the bottom one. Ooh, good job. This by this gives me 6x squared, gives me 3, gives me minus 10, gives me minus 7, gives me minus 5, I think. Double check that. Gives me 6, gives me 3, minus 10 is minus 7, gives me minus 5, yep. So we get that. And if we look at that, it looks like that doesn't simplify. But if we had have looked at it for a second and gone, oh hang on, I'll factorise and cancel them down, this is definitely looking a lot better than that purple boy. So always, always, always flip the thing first and then look for common factors wherever you can. Factorise whatever you can. If there's cross cancellation potential, take it straight away because it makes it smaller, easier to deal with. Just make sure it's actually valid cross cancellation, none of this stuff. Okie dokie. Other little tips for you. We've got something like that, looks like we can't do anything with it. It's like, oh, they're close, but this is x minus 3, this is 3 minus x. Those are around the wrong way, so they're different things. Well, what if we looked at this for a second and leave the top one alone for now and said, 3 minus x, well, I'm going to take out a common factor of negative 1. Okay, well, there's no negative on this, so can I do that? Well, yeah, because if I make that negative 3, negative 3 is 3, and then plus x. Great, so if I expand this, I'll get back to there. So it must be a valid way of doing things, because if I just reverse it, I get back to where I start, that's fine. Well, what if I now leave the top again and say, well, negative 3 plus x, that's the same as x minus 3. Right, okay, well that's fine. And now I've got the same thing on the top and the bottom. So if I cancel these, I'll end up with 1 over negative 1, or in other words, just negative 1. So if you do end up with one of these things where it's just flip-flopped from itself, see if you can shuffle it around and end up cancelling them and getting a negative 1 as a result. Cool. Last little complication. What if you've got a whole chain of these? Which division do I do first? And how do I do it? Great thing about this is you can do them all in one shot. So you flip that over, and now you're just running times all the stuff across the top. Highly recommend you start with the first two and then work your way down, just so you don't overdo it. So I've got x squared minus 3x all over 10, multiplied by 4x plus 1. And then this by this, 4x squared minus 12x all over 10x plus 10. Beautiful. What you might notice at this point, oh, hang on, I could factorize some stuff. I could take out a 4x and then have x minus 3. And then on the bottom, oh, I could take out a 10 and have an x plus 2. Oh, 4 and 10 gives me 2 and 5. Nothing else cancels. Done. So that's as neat as that one's going to get. You could expand this again if you wanted to. That's totally fine. Cool. So, basic points. These work the same way as normal number fractions do. It's just you can get some more interesting outcomes because you've got more numbers to play with. Cool. Be careful about cross-cancelling. If there's pluses and minuses in there, don't cross-cancel. You can only cross-cancel entire objects that are multiplied and divided by each other. Always, when you think you've got to an end, factorise stuff because it might be that there's another factor hiding in there for you. fine. Whenever we're dividing, just remember to flip things over, and basically always write the thing flipped over before you do anything, because otherwise the odds of you making some silly error where you're thinking it's the other way around go up very quickly. So write it flipped, then continue on. And the other bit is just factorize stuff, again, wherever you see it, as best you can, because you can get these free cancellations, which makes things go from that to that in one move, or you can take things that are chunky and turn them into something really nice sometimes. So you always want to try to make things as simple for yourself as possible. Factorizing and cancelling allows you to do that. Best of luck to you. Cheerio.